Hi, gents. We're going to do our first big online lesson here, and what's going to be will be your mock exams. So the way to use this video is to first of all pause it, give stuff a try yourself before me just showing you how to do it. And specifically, it's going to be all the questions from your mocks. So what I want you to do is I want you to pause the video, rewind it. Once it's done, just make sure you can repeat the same task. So we're gonna do paper one, or at least part of it. Depends how long we get through this video. I might split it up into two since it's a full paper. And what I want you to have is I want you to have the paper out in front of you to see how you did. I don't have the marks going for it, but I can tell you at least what the right answers are, or we can figure them out as we go along. What I want you to do for homework, and I'll stick it up as an assignment on Teams, is I want you to go and take a photo of all of your corrections, which should be done on the page. Just send a photo of each page as you go along. So I can just check that you are actually doing it. Okay, the first question, paper one, first question. May as well just say it's paper one. Question one. It's got a list of numbers: 11, root 5, 27, 3.14, 4, a half, 7 cubed, minus 9. And it asks you to give an example, or this is the description. So this will just take a little while. It's a negative number. In fact, it's better if I pause this and just fill it in for you. Okay, there we go. These are the descriptions, and you have to match the number into it as we go along. So we'll do that, and we'll tick it as we go. Okay, let's see. First things first, negative number. So obviously negative number here. Minus 9 looks like our negative number. So we'll put that in and maybe just lightly cross it off just to say that we've used it. A prime number. So a prime number is only divisible by itself and 1. And 11 fits that bill nicely. So there's 11 done. A square number. And if you have a little look at this, that is a number that has been multiplied by itself to achieve that number, okay? Or that's something that started off as a particular number, got multiplied by itself, and then turned into it. So for instance, 4 there, you can write that as 2 squared. So 4 counts as a squared number. Examples of square numbers: 1, because it's 1 squared, 4, because it's 2 squared, 9, 3 squared, 16, 25, 36, 49. Good to familiarize yourself with all those numbers. Those are important ones just to have in your brain. So 4 is our square number. Approximation of pi. It's roughly equal to 3.14. Not exactly. Reciprocal of whole numbers. So we mentioned reciprocal. If you have 2 over 3, the reciprocal is simply 3 over 2. If it's 5 over 7, the reciprocal is 7 over 5. So it says the reciprocal of a whole number. So if you had a whole number, we'll take an example. Let's just say 10. What's its reciprocal? Well, it's 10 over 1, which means that it's 1 over 10. If it's going to be a whole number, it's going to have 1 at the bottom. And therefore, when you do the reciprocal, we'll have 1 at the top. So we're looking for a fraction with 1 at the top, and what do you know? There it is. So that's a half. An irrational number, a number that can't be written as a fraction of whole numbers. And all of them can, apart from root 5. Typically looking for a square root, or maybe you're just looking for a symbol, something like that, for an irrational number if they do ask it again. Now this one here was a bit cruel. Okay, index form of a number. So an index is where you have to a power. Okay, it might be 2 cubed, it might be 10 to the power of 7, something like that. In this case, it's 7 cubed. And I can totally understand why it might have been the case that you thought that 7 cube would go down here. In fact, when I first saw it, I assumed that's what it was going to be as well. It is not. Okay, 7 cube got used up for the index, so what we're actually dealing with is 27. Is 27 a cube number? Well, just remember what a squared number was. 1, 4, 9, 16, 25. Okay, that's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. It is important as well to know what are the cube numbers. That would be 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. I should have written in cubed. So that's 1, 8, and there you go, 27. Okay. I think that's 64. I think that's 125. Though I reserve the right to be wrong on that. So cubed number, so I write in 64 is 27. It's the remaining one. Very easy to write in 7 cubed for that one. I do appreciate that for sure. Okay, so that's our first one down. So that was question 1. Let's click on to question 2. It says, question 2, it's the square root of 56.82 is 24.4 all over 19.18 minus 3.75 times 4.23. Okay, it says round each of the following numbers to the nearest whole number and hence estimate the value of. So what they're telling you to do is round it at the beginning, not at the end. Round each of the following numbers to the nearest whole number and hence estimate. Okay, so they want us to actually go and do that first. So let's see, it's 57 plus 24, and down here it's 19 minus 4 times 4. Be very careful with PEMDAS down there. So we get root, and this thing here is going to be 7781. Okay. And here we have 19. PEMDAS says you must do the multiplication first. So it's minus 16. Okay. If you get the square root of a number that's not nice here, the chances are that you are wrong. Okay. It's a good indication that it's not what they were looking for. So this is equal to 9 over 3, which is 3. So that's our estimate of what it is. That's the A part. Okay, B, using your calculator, evaluate the following correct to 2 decimal places. So what you should simply do is bash it into your calculator, okay, and just go from there. Let your calculator do the work for it. Okay, when I throw that in, what I end up seeing is from my calculator. Now this said correct to 1 decimal place, so don't mess up the decimal place. When I typed it in, I got 2.716567. Sorry, it said 2 decimal places. So again, don't mess it up. 2.7, and this tells us to bring it up. So 2.72. Okay, nothing much going on there. That is just throw it into your calculator. It says find the difference. Difference means subtraction. Difference between this and the value that you just got. And the reason that they're telling you to do that, by the way, I should say, find the difference between your estimate and the true value. I think, despite the fact that it's not terribly clear when it says true value, I do believe what they're looking for is 0.28. So they're looking for you to use 2.72 as opposed to the really long one that's up here. Okay, so I think when they tell you, you can take that, you can take that. And the reason that they're going to do that, you can almost predict it, is they're going to ask you what's the percentage difference or the percentage error in it. Okay, so percentage error, you got to learn this off. It's equal to the actual error over the true value and multiply by 100, okay, to make it a percent. So our actual error was 0.28. The true value is 2.72. As I say, I know that that is not strictly speaking, but it's what they've asked you to take as it. So let's do that. 0.28 divided by 2.72 and multiply by 100. And it says give your answer to one decimal place here. So for me that comes out as 10. It says 29, so that means 10.3%. Okay, so that is question 2. I think that's it entirely done. Yeah, all good. Okay, we'll move on to question 3. Question 3, a really important question. One that I definitely want you to practice out, because it's not one. It was one that I was hoping that we would get a bit more time in school to do. And that just hasn't happened. So what do we have? I will draw this to the best of my ability, which is to say really badly. Yeah, as promised. And let's see, it looks something like this. Okay, that looks about right. Okay, we're told some stuff. We're told that the distance between there and there is x, as it is down here, as it is for this portion there, and for that portion there. We're also told that the whole length is 3 meters, and that entire height is 2 meters. Okay, and they're asking us to get the area of the cross. The cross is this bit here that I've shaded in. Okay, that bit in there, that's what they want. Okay, show that it's equal to something. So there are a few ways to go about this. Okay, we'll do this here. One way that you could do is you could just get, if we just fill that in there, we could just get that shaded area there. Okay, so the area of the blue portion, it's equal to length by height, or whatever you want to call it. LH will call it, the length is 3 and the height is x. So that would be the area of the blue bit. If I change tack and go a different color, we'll make it orange. What we'll also do is we'll get this area in here. It looks a little bit more red than orange, but there we go. We get that area there. Okay, so that's the area of allegedly orange. And that is also equal to length by height. And in this case, the length is x and the height is 2. They're multiplying each other, so it's 2x. But you got to be careful if you add these two things together. Okay, if you add them together, what you notice is that there's one particular portion here that overlaps. Okay, if you add them together, you'll have counted that area in there twice. So if we do want to add them together, and we do, we get 3x plus 2x. What we need to do is we need to account for the fact that's getting the overall area of the thing. We need to account for the fact that we have counted this little bit in the middle twice. So we need to get what that is and just take it away once. And it is, of course, x times x. So it's minus x squared. That's that bit in the middle. So we get 5x minus x squared. And that is what the area of the cross is meant to be. So they just ask you to go and get that, and we have now shown it having done that. There will be other ways to do it. You get the area of the whole thing and start figuring out what that area is there. I might just actually just take the time just to do that very briefly. Okay, how would we get that area in there? And you know what, you should probably stop the video and just try and figure that out. Okay, here's your question. This black portion just in there, figure out what the area is. It's going to have x's in it. Just pause the video and have a go at that there. Okay, I'll just show you how to get that. What you would say is this. You would say that this whole length here, okay, the whole length there is 2. So if you just want this length along with that length, that would be 2 minus x. Okay, it was a length of 2, but you're taking away that green bit in the middle just to leave you with the squiggly portions there. So 2 minus x are both of those. It's symmetrical, so the top bit is exactly half of the bottom bit. So if you want just the top little squiggly bit here, just that bit there. It's 2 minus x divided by 2. That's what you would do for it. And it's the same sort of trick coming along here, okay? The whole way along we know is 3. So just to get the squiggly portions, there's 2 of them. The whole thing is 3, and if we're taking out the bit in the middle, that would be 3 minus x. And to get just one of them, be 3 minus x over 2. Okay, so if you did want to find out the area of that black portion in there, its length by breadth or height or whatever you want to call it, it would be 2 minus x over 2 multiplied by 3 minus x over 2. Okay, that's what you would end up getting. To multiply top by top, bottom by bottom, we would get 6 minus 2x minus 3x plus x squared, and that would be over 4. So we would get 6 minus 5x plus x squared, and that will be over 4. Okay, that's just what it is, just for the sake of it. You know what, I may as well just continue with the question, how many of those things do we have? Okay, we have 4 of them. So if you want the area of all the black bit, all those 4 black bits there, what you would say is that area is 6 minus 5x plus x squared. And if you're looking for just the cross will be the whole flag, which is 3 by 2, 6. Take away those 4 areas. And this is the 4 areas, so we would take this away. Remember, you're taking away all of it. It needs to be in a bracket. So it's going to be 6 minus 6 plus 5x minus x squared. What do you know? 5x minus x squared comes back out again. Definitely a tougher way to do it, but I just want to show you that that is an alternative approach. Okay, that was question 3a. We're now going to go with question 3b. Show that this means that x must satisfy an equation if the area of the cross, okay, that's the area of the cross, is half the area of the whole flag. Okay, well the whole flag is 3 by 2. Okay, area of the whole flag, length by breadth, whatever you want to call it, that's 3 by 2. That is 6. So what we want to say is that the cross has to be half the flag. So you need to really think this one out. Okay, you can't say this, you can't say the flag is the cross, but since the cross is half of it, if you multiplied it by 2, it would get you the area of the flag. So what can we say here? We can say that 6 is equal to 2 amounts of 5x minus x squared. You can instantly divide both sides by 2 and get 3 is equal to 5x minus x squared. And now if we bring 5x and minus x squared over to the left, a much better way to think of it is we're going to add x squared to both sides, and we're going to subtract 5x to both, from both sides. So we're going to add x squared to both sides and subtract 5x from both sides. So there we've done it to the left hand side, and to the right, when you add x squared and take away 5x, we get 0. That's what they wanted us to show would happen, and it has. Okay, so that's the answer to the B part. And the C part is solve this equation. They actually gave it to you. They gave you the equation. Solve this equation to find the value of x and give your answer to 1 decimal place. You should instantly, when you see a quadratic to 1 decimal place, do not try to factorize it. That is not the way to do it. It is going to be the quadratic formula. So A is 1, B is minus 5, C is 3. So we get x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So minus a minus 5, that's plus 5, the square root of minus 5 squared, that will be 25, but not for a minute, a times c all over 2a, 2 times 1. So we get x equals 5 plus or minus the square root of 25. Work out what the sign is first. It's minus by plus by plus. it's in total a minus. So a minus by plus minus. A minus 12 all over 2. X is equal to 5 plus or minus root 13 over 2. Now there are going to be two answers to this, but one of them won't make sense. Try to think why one of them won't make sense in advance. Okay, I'll type this all into my calculator. 5 plus root 13 over 2 press equals, that would be x equals 4.302 blah blah blah. It says to one decimal place, so that would be one decimal place. If I go back up and do 5 minus it, 5 minus root 13 over 2, I end up getting x equals 0.7. One of those doesn't make any sense. And it does not make sense for x to be 4 point something when clearly the whole thing is 2, then x can't be 4. Okay, it doesn't make any sense. So x has to be this thing here. If you just write that, you lose marks because we have forgotten to write in meters. Okay, x is 0.7 meters. Yeah, maybe they wouldn't have taken marks off. They did just say find the value for x. But you know what? Get into the habit of writing in meters as we go along. Okay, so that's question 3. That's a really important one. In fact, I would stop the video and maybe try that out a few times before going on. Just make sure that I could do it, because they love asking that sort of question. So if you struggled with that in the exam, lots of practice with it. Okay, question 4. Okay, Jane buys 800 square feet. Apartment in the US for $270,000. Whereas May buys a 100 square meter apartment in Beijing for 1.25 million yen. That looks things. Okay, and the question is, which is the cheaper based on the cost per square meter? So they actually say you should turn it into per square meter. Okay, so they actually go and say to do that. So I guess that's what we should do. Just either way, we got to make sure that we're either all in yen, or all in dollars, and all in meters squared, or all in square feet. Okay, so that's obviously to make a comparison. You gotta be comparing like with like. So they've asked us to change everything into meters squared. So let's do that. So 1 meter squared, they actually tell us, or 1 square foot. They tell us is equal to 0.093 meters squared. So we can get 800 square feet. Okay, obviously we've taken the left hand side and multiplied by 800, so we should do the same with the right. So 0.93 times 800, that is 74.4 meters squared. Okay, that's what their apartment is. And it's up to you. You can change one thing into dollars, or you can change it into yen. Doesn't really matter which one you want to do. What we do know is that one yen is equal to 0.15 dollars. Okay, so I suppose it's easier just to change it into dollars, really. 1,250,000. Okay, so we've multiplied by 1.25 million. 1,250. Okay, so we multiplied the left by 1.25 million, so we got to multiply the right by that as well. So 0.15 is 187,500. Okay, let's put this all together and do a comparison. Okay, what do we have? We've got Jane, we've got May. Okay, so Jane has 74.4 square meters and paid $270,000, whereas our friend over here, May, has 100 square meters and has paid 187,500 for it. So let's get the price per square meter. That's how you can do the see which one is more expensive. So price per square meter. So 270,000 divided by 74.4. So they are paying $3,629 price per square meter. Okay, that's how much it costs for every square meter. And this one here, obviously we can say that divided by 100 price, that's 1875. That is our price per square meter. Okay, so this one here is cheaper. It says which apartment is cheaper. We'll just actually answer the question. May's apartment is cheaper. Just want to make sure I haven't done anything stupid there. I think that's fine. Yeah, it looks okay to me. Okay. Right, question 5. Okay, question 5. It's a function. F of x is equal to 2x minus 5. Okay, another way of saying that is y equals 2x minus 5. A part 1. Yeah. A part 1. What's f of 4? Well, normally they talk about f of x. So this is telling us to place 4 into the function. Okay, place 4 into the function. X is 4 is another way of saying this. X is 4. So when you have y equals 2x minus 5, y is now equal to 2 times 4 minus 5, 8 minus 5, y is 3. So get the answer there, that f of 4, when we place 4 into the function, we get 3. Okay, part 2, f of minus 2. Another way to think about it, okay, when we place x into the function, we do 2 times x minus 5. So when we place minus 2 into the function, we do 2 times the input is minus 2, minus 5. Just different ways of thinking of the same thing. So we get minus 4 minus 5, f of minus 2 is minus 9. Whereas over here, different question altogether, part 3. F of x is 21. So really what they're saying here, what's f of x? We said f of x was y already, y is 21. So when we have y equals 2x minus 5, that is our function, we're told that y is 21. So it's not that x is 21. And that's all it can be. They're either going to give you x or they're going to give you y. That's really, those are the two options. Add 5 to both sides, 26 equals 2x, so x is 13. Okay. So x is 13, and that is how they would like you to go and do it. Solve the following inequality. We actually did this one in class. That, by the way, it wasn't part 3, just to say that was B. In class, it said minus 11 grade is less than or equal to f of x, which is strictly less than 3, and we're told to graph this, and we're told that we're to graph the real number solution to it. So we'll take f of x. What is it? F of x is 2x minus 5. We're told that. And it's all about how do you deal with this. We did do it in class, so you know what? Take the opportunity to pause it here, give it a shot, see if you remember from class. Okay. What you basically want to do is you want to get the middle thing to be x. So you gotta, whatever you do to the middle, you're gonna have to do to each other thing. Don't try to get x straight away. first of all, get rid of that minus 5. Add 5 to the middle to get 2x. It immediately makes life a bit easier. But if you've added 5 to the middle, you have to add them to both other things. So we add 5 on there, and we add 5, we get minus 6. Okay, what are we going to do now? We're going to just get x. The way you would do that is you would divide by 2. So you must do the same here. Just be careful if you had to divide by a negative number, and we didn't, but if we did, the direction of the inequality would change. Okay. Now what is this? This is asking all the numbers, graph all the numbers, all x's which are less than 4, but greater than or equal to minus 3. So they had a huge big number line here. Minus 5, minus 4, minus 3, minus 2, minus 1. 2, 3, 4, 5. And specifically it wants all of the real numbers. Okay, so is minus 3 included? It is, because it was greater than or equal to, and they're real numbers, so it's a whole line. Real numbers like minus 2.5 is in between minus 3 and 4, so minus 2.5 is included. So is minus 2.51, 2.501, 2.5001. So the way that you draw that is just a full on line. 4 itself is not included, but it's all the way up to it. So you do a line which is just not filled in there for it. So there is your answer. Nice and simple. Hopefully you got that on your practice one, even if you didn't get it in the real thing. So just have another go at it and just make sure that you can do it. Okay, question 6. We've got a Venn diagram. So we did spend quite a bit of time on our Venn diagrams, so hopefully you got this. If you didn't, here we go. 2a, 5, b plus 2, c, b, and they give these names. That's p, that's q, that's r. And we're told that given that the cardinal number p intersection q is 6, find the value of c. So what does that mean? First of all, cardinal number, that symbol, the octothorpe there, not a hashtag. It is a hash, but it's not a hashtag. That means the number of elements, or the number of things which are in p intersection q. So you need to go to the intersection, and we'll use our, there's where they overlap. Okay, that area there is where they overlap. So what we can say here is we can say that that area there, which is c minus 3 plus an additional 5, it's the overlapped area, that's equal to 6. So we get c plus 2 is equal to 6, so c is 4. Okay, and it makes sense. If you make c 4, then that little bit just in there becomes 1, with the additional 5 means that the overlap between C and P, P and Q is going to be 6. You'll have 1 and 5. So there you go, that's that first bit done. Given that, this thing here. So again, the octothorpe just means the number of things in, and this says Q complement. That little dash there means complement. That means everything that isn't in Q. Okay, the exact opposite of Q. So there's, maybe if we again use a red pen. Okay, there's Q. So it's the exact opposite of Q. So really what they're saying to us here is they're saying to us that A plus B plus C is equal to, and we're told that this thing is 19. Okay, so A plus B plus C is 19. We already know that C is 4. So we can say that A plus B plus 4 is 19. So we get that A plus B is, subtract 4 from both sides, 15. Now what's the question? The question is, if that were true, if this thing is true, write an equation in terms of A and B. So write an equation that has A's and B's only in it. And look, we've already done that. Okay, so it's quite a natural thing to follow on from that. So that's the B part. C part says, given that the number of things in the cardinal number of Q less P. So you start off with Q and then you just eliminate anything that is in P. Apparently if that's 25, write another equation with A's and B's. So we can already tell this is going to be a simultaneous equation. So what was it, Q less P? Yeah. So you start off with all of Q. There's all of Q, just visualize it there. It's the whole thing. Okay, it's the 2a, it's the c minus 3, it's the 5, it's the b plus 2, all of Q, and you take away from it anything that's in P. What are you left with? So you're left with 2a, and you're left with b plus 2. So 2a and b plus 2. So we can say here that 2a plus b plus 2 is equal to 25. Make an equation. We already have, but we should tidy it up. You would be expected to do that. Subtract 2 from both sides. Equals 23, and no prizes here is the D part, saying to do simultaneous equations. It is. Use your answer from those two things here. So there we have it. 2a plus b equals 23. Pause the video. Go and show that you can solve simultaneous equations. That's our first equation. That's our second equation. Pause it. Give it a shot. Okay, what it says here is that we got to do some simultaneous equations. So to do that, take 1 and multiply everything by minus 1. Minus a minus b equals minus 15. Why are we doing that? So when we add the two things together, plus b and minus b will give us nothing. So we'll get rid of the b's effectively. So just do what it says, just add going down the way. 2a minus a, that's a single a. B minus b, that's nothing. That was the whole point. And 23 minus 15 leaves us with 8. So we've just got that a is 8. And we also know that a plus b, what was our equation, is 15. So you just have to sub in that thing in there. A is 8. So 8 plus b is 15. So it turns out that b has to be 7. Okay, there's our answer. A is 8. B is 7. Hopefully you got that. Hence or otherwise for the E part. So hence just means following on from that. Find the number of things, the cardinal number, the number of things in P union with Q union with R. So that's just everything, okay? Union means the whole lot of it. Okay, so we'll fill that in. What was it? A was, I think A was 7 or 8? A was 8. 8. B was 7. C was 4. So we'll just fill that in. That's 8. C was 4, so 4 minus 3, that's going to be 1 in there. A is still 8, so we have 16 in there. B is 7, so B plus 2 is 9. And B is still 7. So we just got to add those up along with C, which is 4. So we'll just do that. It's 9, that's 10. Is there any nice way to do this? I presume not. So 10, so we'll just do it like that. We've got 18, we've got 27, we've got 34. So that to me looks like 50. Looks like we have 50 things in there. So that is 50. Obviously check your answer, but that looks right. Okay. Let's see. Looks like for question 7, I'm gonna have to write out quite a bit. So you know what? I'll skip question 7. I'll do it in the next video. And just looking at it, I think we'll finish here with question 8. So I know that that's slightly out of order, but not a problem. Okay, factorize each of the following expressions. So question 8a, part 1. I will come back to question 7 just in a different video. 2x squared minus 50. There's one thing that you should be good at. It is factorizing. And it says factorize fully. that means that there might be more than just what meets the eye here. So always check, is there a highest common factor? There is not. There is in this case. It's 2, and it's x squared minus 25. And then what you'll notice is, hopefully, you'll see that this thing is the difference of two squares. So it is 2 amounts of x squared minus. So this is the way to do it, is what I would suggest. Forget about the 2 for a second. So it's going to be the difference of two squares. Write in something squared minus something squared. In this case, it's x and 5. So it's 2 amounts of, and just do the difference of two squares, x minus 5 times x plus 5, something we've done a million times in class. So there you go. 2 times x minus 5 times x plus 5. That's all you have to do. Our next one, part 2, is going to be, looks very much like grouping, because there's 4 terms. First thing to do though, is there a highest common factor? Is there something that divides into everything? And there isn't. So next thing you do is you pair it into groups. Is there something that factorizes between there and there? Yes, there's a 3. Is there something that goes in between there and there? There is. But this might not work out, but we'll have a look. Maybe we'll. If we put in 3, we might need to rearrange this. That's my first instinct, but we'll just look at it. What do we get? 3 times AB minus 2C. Now over here, if we wanted to factorize, now it is going to work out. If we want to factorize, you have a choice, but only one choice is correct. Okay, so let's just talk about this. Minus a squared b plus 2ac. What can you factorize? Sure, you can factorize out an a, and you will get minus ab plus 2c. That's what you'll get. You can also factorize out a minus a. Both these things are the exact same. What do we end up with? We'll end up with ab minus 2c. Okay, and that's actually the one that you want to go with, because you want to have the same thing in the bracket. Both of those are the same, so that's why it's the right answer. Factorize out a minus a, but you did have options. Now we have the exact same thing, so we write it down. ab minus 2c times 3 minus a. That's your answer. If you're not sure about that, think of AB minus 2C as a number. Call it Steve. What do we have? We have 3 Steve. Don't forget good old Steve. Minus a Steve. What's the highest common factor? It's of course Steve. And he divides into the first one to give 3 and into the second one to give minus a. And of course Steve is AB minus 2C. It's a bit unorthodox, but there you go. It also works if you wanted to. Okay, B part 1. Factorize 6x squared minus 19x plus 15. Don't use the formula. It didn't say solve it, just said factorize it. Now, is a bit of a pain because there are multiple options in every sense. So I'm going to make those options here. You get to see me struggle to do this live. So we've got 6x and x. Okay, that would make 6x squared, but the other option is 3x and x. What you want to put in is you want to put in the numbers there that multiply, or potentially over here, to give us 15. Okay, sorry, when I say 3x and x, I meant 3x and 2x, of course. So things that multiply to give us 15. 1 and 15, 3 and 5, that's it. 1 and 15, 3 and 5. Notice that the numbers multiply to give plus 15, but they're going to add together, whatever we get here, they're going to add together to give minus 19x. There is only one way for that to happen. They both have to be negative. If they were both, so to get plus 15, they either have to be both pluses or both minuses. But if they're both pluses, they'll add together to give a positive number as opposed to minus 19x. So that bit we can be sure of. Okay, and now it's just about placing in the numbers to try and get the thing that we want. So for instance, if you did put in 15 and 1, we get minus 15x, we get minus 6x, but that would add up to give us the wrong value. It would give us minus 21x and not minus 19x. So it's not that. And look, if you have to try every single combination, then you try every single combination as you go along. Looks to me, just off the bat of it, if we put in 15, not going to work into either one. If we put in 5 in here, we'll get 30, not going to work. We place it in here, we're going to get 5 along with 18x, so no way to get 19x there. So I'm turning my attention now over to here and having a look at this. So if, for instance, we place in 15, 15 is instantly going to be too big on either one. So hopefully now if we stick in 5 somewhere, this is going to work. So let's just do the wrong one, as it looks like to me. That would be 15x minus 15x and minus 6x doesn't work. So 5 and 3 hopefully will, or else we're in big trouble. Minus 10x and minus 9x, there you go. Minus 19x, so that is our answer. Our answer is 3x minus 5 times 2x minus 3. And really important that you can do that. Part 2. Look at this. If you read part 2 in advance, you would have known the answer to the one above, or it would have been a real big clue to the one above. It says simplify the following. And there is the exact same quadratic all over again. And if it says simplify, it really means that you're going to be able to divide top and bottom by the same thing. So you would have a really big guess that one of the factors is 2x minus 3, which it is. So actually you can, if you already know that, if you know that 2x minus 3 is going to be one of your answers, you can create the other solution. You know that it's got to be 3x, 2x and 3x making 6x squared, and minus 3 multiplied by minus 5 gets you plus 15, and you can just do a double check. So actually there was a way to figure that out without even knowing how to do quadratics basically. But anyway, we were pure about it. We got our right answer. It's 3x minus 5 and it's 2x minus 3. And you're simply dividing top and bottom by the same number, okay? You can't just like get rid of the 2x's or something appalling like that. It's got to be the whole term, okay? You're saying, how many 2x's do I have on top? Because you're dividing by 2x minus 3, sorry. How many 2x minus 3's do I have on top? I have one of them. How many 2x minus 3's do I have on the bottom? I have 3x minus 5 of them. So there we go, that is our answer to question 8. Okay, I think now is probably good time to stop. I'm going to make out a second video that's got the rest of the answers for all of paper 1. I want you to correct them and send them off to me. Wait till that second video is up for you to send it in, and I'll make it an assignment to make sure you are actually filling those out. Okay, gents, I hope you're keeping well, and we'll catch you soon. Hopefully you found this useful too. Cheers.